week 11. Um, I assume you know the tutorial sheet, which is, so you go to the course website and go to week 11. Right, this is, sorry, this is week 11, right? This week 11, and click on the tutorial sheet. This is the tutorial sheet for today. So as you can see, there are 7 questions. I will try to do as many as I can, okay? And as usual, for all your questions, please use the chat room, okay? I'm happy to answer all your questions in as much detail as possible, okay? All right, guys, okay, so let me start with question number 1. So let me change the channel. Um, Excuse me. All right, let me change the. All right, so this is question 1. If you cannot see this clearly, I mean, I'm still using the visualizer. I'm the one I bought online. Um, so if you cannot see this clearly, please have a look at it. Look at the one on the course website, which has the PDF version. All right. So basically, this question says the mean breaking strength of a component is 200 kg, and the standard deviation is 30 kg, right? And you're told that you're taking a sample of 40. You're taking a sample of 40 uh, components, and you want to test mu equal to 200 versus mu not equal to 200, and mu equal to 200 versus mu greater than 200, and using 2 different values for alpha level of. Remember, alpha is the level of significance. And you're also told that the sum of the data values for the 40 components that we took is 8328.4, right? So all right, let me show you how to do this. So I will start with part 1. So remember, part 1, we are trying to test mu equal to 200 versus mu not equal to 200. So this is question 1, part 1, okay? So in this case, all right, first of all, we are assuming that the population standard deviation is known and is equal to 30 kg. Now, if you look back in the stuff that I did last week in week 10, um, this is one of the cases I considered where you have a random sample from a normal population where the population variance is known. And I gave you the rejection rules for corresponding to 3 sets of hypotheses. This is the hypothesis where mu is equal to something versus mu not equal to something, and this is the corresponding rejection rule. Now, in part one of this question, we are testing for mu equal to something versus not equal to something. So the rejection rule that we need to use is this one, right? Okay, so let me write that down first. So the rejection rule that we need to use is this one. Right, let me put this in a box. You will see why I'm doing this in a second. And let me call this equation star, right? Now what I'm going to do is I'm going to compute the left-hand side and the right-hand side and see if this inequality holds or not, all right? All right, before I do that, let me write down what is given to us. You're told that n is a sample size is 40. You're told that sigma is equal to 30 kg. And you're told that mu zero, the value that you're testing for, is 200. And you're told that x bar, remember x bar is a sample mean, right, which is 1 over 40 times the sum of xi, 1 to 40 of xi. Now you're told in the question that the sum of xi is 8328.4. So this is basically 8328.4 divided by 40, right? Which, if you do this, you will get this to be 208.21, right? So this is all the data that's given to you, right? And you're also told to use two different values for alpha, alpha 0.05 and alpha 0.01, right? Okay, so let's see how we can do this. Okay, before I consider alpha, let me compute the left-hand side of star. The left-hand side, which is this guy here, it's gonna be root of 40 divided by 30, the absolute value of 208.21 minus mu zero, which is 200, right? And if you work this out using a calculator, this will be 1.731. So this is the left-hand side of star. Okay, now the right-hand side of star involves alpha. So we need to consider, okay, let's suppose alpha is 0.05. Okay, then the right-hand side of star in this case will be equal to Z 0.975, right? And this, if you read this off the normal table, this is what you will get. So this is the right-hand side, and this is the left-hand side. And clearly 1.731 is not greater than 1.96. So the conclusion is that we cannot reject the null hypothesis. Remember, we reject H0 if this is greater than this, right? So the conclusion is that there is no evidence to reject H0, right? So in other words, we accept the alternative, right, hypothesis, okay? That's if alpha is 0.01. Now let's consider the case where alpha is 0.01. In this case, the right-hand side of star will be equal to Z 0.995, right? And this, if you read this off the table, this will be 2.576, right? And if you compare 1.731 with 2.576, once again, you see that this is not greater than this, right? Hence, the conclusion is the same. That is, there is right. Okay, are you guys okay with this? Before, I want you to understand this clearly before I go ahead. So can you please tell me if if you followed this okay or not? If not, just please feel free to say so. I'm happy to go over. Okay, are you guys all okay? Okay, thank you. All right, then, so this is only the first part of question one. The second part of question one, the second part of question one is asking you to test mu equal to 200 versus mu greater than 200. All right, now you should go back to the formula sheet. You should go back to the formula sheet. These are the three hypotheses I considered last week. Now, the second hypothesis is where mu is equal to something versus mu greater than something, and the corresponding rejection rule is this one, right? Okay, so we need to use this one as the rejection rule to do part two, right? So that's what I'm going to do now. So let me get a paper just a minute. So I'm going to do part two, question one, part two. So here we reject the null hypothesis if root of n divided by sigma times x bar minus mu 0 is greater than z1 minus alpha, right? So this is the rejection rule, right? Okay, once again, let me put this in a box. Okay, call this star, right? Now, let me write down once again the data that is given to us. We are told that n is 40. We are told that sigma is 30, right? And we know that mu 0 is 200. And we know that x bar is 208.21. Okay, so subbing all this data into this equation, the left hand side uh, becomes equal to the following. Right, and if you work this out, this will be 1.731, right? The right hand side, okay, in order to compute the right hand side, we need to consider the different values for alpha. So suppose first alpha is 0.05, right? Okay, in this case, the right hand side is gonna be Z 0.95, right? And this is 1.645. Okay, so this is the left hand side, 1.731, and this is the right hand side. And clearly 1.731 is greater than 1.645. So the conclusion here is that there is evidence to reject the null hypothesis, right? Because the left-hand side is greater than the right-hand side. Okay, so we reject the null hypothesis, right? Okay, so that's only if alpha is, okay, now let's consider a case where alpha is 0.01. In this case, the right-hand side of star is at 0.99. And if you read this off the normal table, you will get 2.326, right? Okay, so now if you compare these two numbers, clearly this is not greater than this number. So the conclusion here is that there is no evidence to reject H0. All right. Okay, guys, are you okay with this? Let me know if you're not okay. I'm happy to go over again. Oh yeah, Lakita. Yeah, the reason is Lakita. In the last question, in the last part, yeah, when alpha is the right hand side is 1 minus alpha by 2. So when alpha is 0.05, you get 0.975 because of this. Whereas in the second part, Lakita, if the right hand side is 1 minus alpha. So when alpha is 0.05, you get 0.95. Okay, you get that? Okay, thank you. All right, any other questions, guys, on part two of question one? Hello, guys, talk to me, please. Any questions, I'm happy to answer. Thank you. All right, so let's go to, so we're done with one. The question two is, we have a random sample of size 10 from a normal distribution with the variance equal to 3 and the sample mean equal to 0.7. I'm sorry if you cannot see this, but let me try to adjust. This is slightly better, I guess. I don't know. I'm sorry about the visualizer, but all right. So you have a sample of size 10 with sigma squared equal to 3, sample mean equal to 0.7. We are trying to test this versus this at 5%, right? Okay. So once again, we are assuming that the population variance is none. So once again, the rule that we need to use is the first one, because if you look at, sorry, not the first one. Here, we're testing for mu equal to 0 versus mu greater than 0. So the one we need to use is the second one. It's the second one here where the population variance is none. So we need to use this rule once again to do question 2, part 1, right? All right, so this is question number 2, part 1. So we reject H0 if root of n divided by sigma times x bar all right, so this is the rule for rejection. Okay, right, now let's go back to the question and see what we have, right? So we are told that n is the sample size is 10. We are told that sigma squared is equal to 3. We are told that x bar, the sample mean, is equal to 0.7. And we are told that mu0 is equal to 0. And also we are using 5%, so alpha is 0.05. So this is all the data that's given to us. Okay, so subbing this into the formula, you will see that the left-hand side of star is equal to root of 10 divided by root of 3, 0.7 minus 0. Right, and if you work this out, this will be 1.275. Okay, whereas the right-hand side of star is alpha is 0.05. Okay, so this is gonna be 0.95, right? And if you work this out using the table, this is 1.645. So these are the two numbers you need to compare. Clearly, this is not greater than 1.645. So the conclusion is that there's no evidence to reject the null hypothesis. Okay. All right, guys. Are you okay with this? No. If you're not okay, let me know, guys. I'm happy to answer all questions you have. Okay. All right. Okay. So let's move on to the second part of question 2. So this is part 1. It's similar to what we already done. Part 2 of question 2 is asking you to calculate the type 2 error probability if the true value for mu is 1 and if the true value for mu is 1.5. Now, I think you probably remember from last week what type 2 error is, right? So this is question 2, part 2. Now, the probability of type 2 error, which we normally denote by beta, right, is defined as the probability of accepting the null hypothesis when H1 is true. Okay, you follow? All right, now let me go back to this. Right, now we know from part 1, this is the rule for rejecting the null hypothesis, right? So the rule for accepting the null hypothesis will be the opposite of this, which is okay, and mu zero, the h1 is the rule, is the hypothesis that mu is greater than 0. Okay, guys, right. Now let's sub in the numbers. We know that n is 10, and we know that sigma squared is 3, so sigma is square root of 3. We know that mu 0 is 0, and we know that alpha is 0.05, so this guy is 1.645. Okay, guys, are you with me so far? If you're not, please use the chat room. Okay. Now we should go back to the question one more time. The question is asking you to compute this probability at mu equal to 1 and mu equal to 1.5. All right. So first of all, I'm going to assume that, let's suppose that mu is 1 first of all, right? So in this case, this probability is, yeah, it becomes like this, right? All right, in the next step, I'm gonna apply a trick. I think I did this yesterday too. What I'm gonna do is I'm gonna write X bar as follows. You see in a minute why I'm doing this, right? Now, I'm gonna take this one here to the right-hand side, okay? Now, if you do that, this is what you will get. You will get the probability that, okay, you get this, right? Now, you should look at this. Does this ring a bell to you guys or not? I mean, I talked about this yesterday in the review session. Do you see what this is, guys? Now, if you don't remember, let me write it down. Sorry, it's rude. Yeah, thank you. Thank you, look at that. So if you don't remember, let me write this down. This is a result I mentioned several times in the class, uh, in the class, including yesterday, that if you have a random sample from a normal, then this guy here has a standard normal distribution, right? You remember this? Yeah, okay. So using this result, guys, I'm going to argue that conditional on the population mean being equal to 1, this must have the standard normal, right? So what you have is the probability that NO1 is less than or equal to 1.645. Take away this. All right, we don't need the conditioning anymore because we have used the conditioning that the population mean is 1 to argue that this has the standard normal. So we have used the conditioning, so you don't need it anymore, right? And finally, this you can write as the phi. Remember, phi is the CDF of standard normal. Okay, all right, now if you work this out using the table or some of the means, this is what you will get, 0.43. All right, guys, are you okay with this? This is part 2 of question 2. If you're not okay, please let me know, guys. I'm happy to go over again. Okay. All right. Yeah. Okay. All right. So this is only when the true population mean is 1. Okay. Now let's repeat this exercise when the true population mean is 1.5. All right. So I'm going to go back to this line here, and I'm going to say that the true population mean is 1.5. Okay. So in this case, the probability, this probability will become, okay, right. And the next thing I'm going to do is I'm going to, oh man, sorry, running out of ink. The next thing I'm going to do is I'm going to, as I did earlier, I'm going to subtract the true population mean and add the true population mean, right? Okay. Now, and the next thing I'm going to do is I'm going to take this term to the right-hand side of the inequality. So this will become the probability that sorry, this is root of 3. I'm missing the root again. Okay, condition on the mu equal to 1.5. All right, and okay, now I'm going to argue that this guy here, right, should have the standard normal because we are conditioning on the true population mean equal to 1.5. So it's the same argument I used over here, right? Okay, so using the same argument, we can say that this probability is equal to NO1 less than or equal to 1.645. Yeah, okay. And finally, this is the CDF of the standard normal at 1.645. Okay, and if you work this out using the normal table or some other means, you will get this to be equal to 0.14. Okay, guys, are you okay with this? So this completes part 2 of question 2. If you're not okay, please let me know. Okay. All right, now let's go to part 3. So we've done the first 2 parts of question number 2. Now part 3 of question number 2 is saying the following. Assuming the sample mean remains the same, how large would the sample size need to be in order for H0 to be rejected in favor of H1, right? Okay, so let's see how we can do it, right? So basically, it's asking you for the value of n. So this is question 2, part 3. It's asking you for the value for n such that this rejection rule holds, right? So basically, so you have root of n divided by sigma. Sigma is root of 3. X bar is, we know, is 0.7. Mu 0 we know is 0. It's greater than, we are using 5% significance. So this is 1.645, right? So you have this inequality. And the question is, what should n be, right? So it's just a calculus on, it's just a simple mathematical exercise, right? So you have, yeah, and you should take the square both sides, right? This will become, if you use a calculator, this is equal to 16.5675, right? And clearly the sample size cannot be a decimal number, all right? So that implies that n, the minimum value for n should be 17. All right, guys, is that okay or not? Hello, guys, talk to me. You being, are you guys okay so far? So I just finished the solutions to question number 2, right? All right. So the next question I'm gonna do is 3. So we're done with 2. So question 3, let's read it. So you have a random sample of size 250, and the sample mean is this figure here. The sample variance is this figure here, and you're testing this versus this at 5% level of significance, right? I don't know why I keep doing this. Sorry, guys. Okay, maybe. Right. So clearly, in this question, um, the question says what the sample variance is. So which means that the population variance is not known. So if you go back to the formula sheet, you cannot use any of these formulas because we are assuming that the population variance is known, right? So none of these formulas can be used to answer question 3, right? So let's go back to the next sheet that I showed you. Right, in this case, we are assuming that the population variance is unknown, right? And these are the 3 rejection rules corresponding to the 3 sets of hypotheses. So if the hypothesis is something like this, then this is the rejection rule, right? So for question 3, we are testing this versus this, right? So the rejection rule that we need to use is this one, right? Okay, so let me write that down. Let me write that down. Excuse me. So this is question number 3, right? So the rejection rule that we need to use is that we reject H0 if root of n divided by s times this is greater than this, right? This is the percentile of the t distribution, right? So once again, let me put this in a box, right, and call this equation star, right? So what I'm going to do as usual is going to compute the left-hand side, compute the right-hand side, and compare them, right? Okay, now before I start, let me write down all the data that's given to us, right? All right, according to the question, the n is a sample size, is 250. The sample mean is 1794.6. The sample variance, which is S squared, is equal to 2484. Mu0, which is the hypothesized value, is 1800. And alpha is 0.05. So these are all the data that's given to us, right? So all we need to do is to simply compute the left and the right hand side. So let's start with the left hand side. Right, so this is gonna be root of n, which is root of 250, divided by s, which is root of this, x bar, which is 1794.6, and mu zero, which is 1800. Right, now if you work this out using a calculator, uh, this is what you will get. Okay, and the right hand side, of star is t. Now n is 250, so n minus 1 is 249, and alpha is 0.05, so this guy is 0.975, right? Now, if you read this off the table for the t distribution, this is what you will get. Now, by the way, I'm sure, do you know where to find this table? You should go to the course website, and there's a link called formulas, and if you click on that link and go to the bottom of that page, you will see a table for this. But 249 will not be in the table, I think. So you need to look up something that is the closest to 249. Okay, or you can use R. If you know how to read this in R, I think I showed you how to read percentiles in R, so you will get something like this. All right, so this is the left hand side, and this is the right hand side. Clearly this is not greater than this, right? So the conclusion is that there is no evidence to reject the null hypothesis. Okay, guys, are you okay with this? Any questions on this, guys? So this question is slightly different from the two previous ones because we need to use a different rejection rule, right? Which involves the percentile of the t, right? Any questions, please? Hello, guys, talk to me. You guys okay? Okay, thank you, Cameron. Okay, let's go to the next question then. So we're done with question number 3. Can we do question 6? Yeah, somebody, Robert. Okay, question 6. All right. So here you have this question is on proportions, right? Clearly, as you can see, it's a question on proportions, right? So you have a US journalist, it's just a polling organization, and you're choosing 920 individuals, and of those individuals, 478 said they are concerned about the lack of educational TV programs. So let P denote the proportion who are concerned about this issue. So the first part is to test P equal to 0.5 versus P greater than 0.5. I'm sorry if you cannot see this. Yeah, but if you cannot see this, can you look at the course website, which has the PDF version, right? All right, so we are testing for proportion P equal to 0.5 versus P greater than. So the rule that you need to use, the rejection rule that you need to use is this one, right? Remember these 3 rejection rules I talked about last week. Now we are testing for P equal to something versus P greater than something. So this is the rejection rule that we need to talk about, right? Okay, so let me show you. So let me write it down. So this is, thank you, Robert, for bringing this up. So the rejection rule, the reject H0 if n divided by x bar times 1 minus x bar in root times x bar minus p0 is greater than z 1 minus alpha. So this is the rule. This is the rule for rejecting, right? Now let me call this as usual star, right? Now let's write down what is given to us. N is the sample size, which is 920, right? X bar is the sample proportion. So it says 478 out of 920 were concerned that there were not enough, uh, TV programs on education, right? Okay, so, and what else we know? We know P0. P0 is 0.5, and alpha is the 5. It doesn't say what alpha is, but assume is 5%. I think I assume is 5%. So let's take alpha to be 0.05. Okay, so given all this, yeah, this is the test statistic, Robert. I mean, I gave it to you last week, Robert. So you should go back to the stuff I did last week. This is stuff I did last week, Robert. This is the test statistic that you need to use. This is the rule that you need to use, right? Okay. So, all right. So the left-hand side of star is gonna be n, which is 920 divided by 478 divided by 920. 1 minus 478 divided by 920. So all thing in square root, right? And then x bar is this guy here. And P0 is half, 0.5. Now, if you compute this using a calculator, this will be 1.1869, right? And the right-hand side of star, which with alpha is 0.05, is 1.645, right? So this is the right-hand side, this is the left-hand side, okay? And clearly, this is not greater than this. So the conclusion is that there is no evidence there was no evidence against H0. So in other words, there is no evidence that the proportion of TV programs on education is not equal to 0.5, because remember, we are trying to test the hypothesis that P, the proportion, is 0.5 versus P is greater than 0.5. All right, so that's part one. Part two is, oh yeah, we have already done, I mean, I think basically we have already done part one, part two, and part three, right? So we have done the first three parts in this question. So what I have done here is part one to part three, right? Okay, I mean, okay. So we have done the first three parts of question 6 in this stuff I have just written down. Okay, is that clear, Robert, or any other guys here? Are you guys okay with this? So this is the solutions to the first three parts of question 6, right? Now the last part of question 6 is asking you, what is the probability that the test procedure rejects H0 when the true value for P is 0.55? All right. Now to do this, I don't know if I have the time, but I will try. So I will try to do part 4. This is question 6, part 4. So it's asking you for the probability that we reject the null hypothesis when the true value for the proportion is 0.55. Okay. Okay. So now we know from the earlier part, that is, we know that this is the rule for rejecting the null hypothesis, right? Which is um, x bar. Sorry, let me write it down. N is okay. Let me just put it as n. Okay, instead of putting in the numbers. Okay, this is all right. X bar is x bar, and p0 is 0.0.5. Okay, given p equal to 0.55. Okay, right. Now what I'm going to do is, as I did earlier, I'm going to change 0.5 to 0.55, and the reason for that, you will see why I'm doing this in a second. I'm gonna change this guy here to 0.55, right? Because we are taking the true population proportion to be 0.55. So to make up for this, you need to add zero point zero 0.05, right? Okay, all right. Sorry, I forgot to put the equality. So this must be greater than this, which is 1.645. I forgot to put this. Sorry. Okay. Right now, the next thing I'm going to do is I'm going to take this guy here to the right-hand side of the inequality, right? Okay. So doing that, it will give you greater than. Okay. Conditional on p being equal to 0.55. I'm sorry for my messy writing. I apologize. I hope you can read my writing. Oh, hope so. Okay. All right. And in the next stage, okay, I'm going to argue that, I don't know if you guys remember this. When I talked about the binomial distribution ages ago, I think it was a long time ago, maybe it was week 4 or week 5. Um, One of the results I showed you is that if you have something like this, right? And you're conditioning on the true population proportion equal to 0.55, right? Then, okay, let me write it down if you don't remember. So maybe you might have forgotten this. If you have IID from a binomial distribution with parameters m and p, right? Okay, um, then um, oh, is it? I think it's not binomial. It should be Bernoulli. Excuse me. It should be Bernoulli distribution with parameter p, right? Then one of the results I proved uh, way back long time ago is the following. Mm, you might have forgotten this. I don't know. You should remember this. I don't expect you to remember this now, because I did this long time ago. So this is the result I proved some time ago, right? So using this result, right, you can argue that the right left-hand side has approximate standard normal distribution, right? So this is approximately equal to the probability that N01 is greater than 1.645, take away this, right? Okay, guys, now I'm sure you know how to do the rest, right? I mean, then this you can write as 1 minus capital phi at 1.645, take away this, multiplied by 0.05. Now you can sub in the value for n and the sub in the value for x bar. And if you do the math for this, you will get the answer to be 0.992. All right. Sorry for my messy writing, but I hope you followed what I did. So this is the answer to question number 6, Robert and others. Did you guys follow this or no? Let me know. Hello guys. We also run out of time now. Exactly. All right. So the crucial result I have used is this result here, which I proved quite some time ago. You may want to look at the video on the binomial if you forgot this result. So to go from this line to this line, I used this result, right? All right, guys. So I'm sorry I haven't been able to do other questions. So I only did 4 of the 7 questions. But the 3 remaining questions, I will post the full solutions tomorrow because we have a tutorial tomorrow. So tomorrow afternoon, you should be able to see the full solutions in typed form, in as a video solution, and also as a handwritten form solution. All right. Okay, guys. So any questions, please, as usual, please feel free to contact me 24/7 by email, Skype, Zoom, or phone. You know my phone number, 01612732941. Okay, and have a great morning or afternoon wherever you are. Okay, and please take care of yourself. Um, Thank you, Robert, for your real help. I really appreciate it for everything you've done. Okay, thank you. Thank you so much. All right, take care, guys. For any questions, please feel free to contact me 24/7. Okay, and I will send you your marks and the feedback for the quiz number 10 in the next half an hour or so. So check your email in the next half an hour. Okay. Thank you, guys. Take care.